All right, so again, hopefully it is broadcasting correctly. If not, we're going to have to take a couple minutes here to figure that out. But otherwise, today we're going to continue with Java. And we left off last time looking at dynamic collections. We looked at lists and sets. And then I gave you a preview of something even more powerful, a map. All right, well, let's make sure that if you have questions, nope. All right, it does suck. All right, so I'm going to go ahead and stop the stream for a second and then all right. I don't know if we're back live, but it's still not broadcasting correctly. Yeah, stop streaming it. Let's see if okay. So there we go. We're going to have to hopefully it's not too bad resolution for you at home. Otherwise, the notes will be posted, of course, so we should be okay. All right, let's go ahead and get rid of that. Again, if you have any questions or if you, at home, if you see any other issues, please go ahead and post a Piazza. Anyway, back to maps here. This is the example that I gave last time where we've got nicknames, right? So we're mapping a string to a string. And the syntax for doing that is simply that I'm going to create this map, and remember that these are parameterizations. This class, this instance, is applicable to these types. And when I did that with a list, I said that this list is good for strings, or this list is good for integers, or something like that. This map maps strings to strings. And you can put them in, and you can take them out. The way that you can get, these are called keys, and these are called values, right? So these maps map keys to values, right? And based on the key, you can get the value. Just like an array, the keys there are contiguous integers, 0 through n minus 1. And so you can easily get the value if you know the key, right? The key turns the door and it opens it and gives you the value. All you have to do is use the get function. So nicknames. Suppose that I want to get my nickname, Christopher. There we go. And of course that returns a string because I'm mapping this string to this string, this value over here. This is the key, this ends up being the value. And so I need to capture that value that it returns. String s is equal to this, right? And then I can output the results. So of course Christopher maps to Chris. What happens when I do something like this? What happens when I use an invalid key? I don't know, Mike, okay, or Michael, right? Because we're mapping names to nicknames. I want to get Mike out of that, right? What's going to happen here? That's a key that I've not put into the map yet, right? So what's it going to return? Null, right? It's not an error. It doesn't blow up in your face. It's not like one of those exceptions. It's just that you get back null. Now, how do you know that you originally mapped that key to null? There are some other things that you have to check, and you'll have to read the documentation for that. But otherwise, this is a super useful data structure. Once you get the hang of it, you will be using it all over the place. You will never ever use another traditional array, or maybe even array list for the rest of your life. Once you've got a map, you can do so much more. Okay. It's one isn't full screen. No, it's not full screen because we had to change it at the beginning. But hopefully it'll be fixed by next time. So hopefully it's higher resolution now too, because I am getting better throughput here. Okay. So thanks for pointing those out online. If not, of course, I can do this lecture again today and then post it online as a recording or something. I'll check out the quality later on. But anyway, what else can you do with a map? Well, all you have to do is RTM, read the documentation. And for that, all you have to do is, Google it. I'll bring over my web browser over here. and Java map, or map. Not maps, but map will come up. And you get all of these methods that you can call on it. You can get the collection of values. So if you don't care about the keys and you just want to dump all the values, fine. It'll return a collection of all the values. If you want all the keys, it'll give you a key. Now it's a set of keys. It's unordered because a map is unordered. It's not in alphabetical order necessarily. That would only make sense anyway if you were mapping strings to something else. What if you're mapping foo to bar and you don't even know anything about foo, right? There's no order to foo. There may be no order to foo. But you can do it with anything, right? You can map strings to integers, integers to strings. All you have to do is parameterize it. I'll map integers to strings, or maybe strings to integers. Equals ages, right? Equals new hash map. And if I want to, I can go ahead and put on all these, oops, sorry, there we go. And I can put in their ages. So nicknames dot, or not nicknames, but ages now. Ages dot put, maybe Chris dot put, or Tommy say. His age is, I don't know, 21. Right? Ages dot put, Chris. I'm 30 something, right? 30 something in quotes. Is that right? Well, here, let me fix that and put in put. Is that right? I'm not 30. It's a compiler error because it knows I'm lying, right? No. What's wrong here? I'm trying to map a string to a string. That would be perfectly fine if I was using the nicknames map, but that's not what I parameterized it for. I said that I'm mapping strings to integers, and I'm trying to map a string to a string. That's not going to work. Once I do that, then it's true. And now it knows that I'm not lying, right? I am 30. No, I'm not. All right, so you can string these things together. You can have a map to another map to another map. Just like you might be taking 235 right now, discrete mathematics, and eventually you're going to be talking about functions. You've talked about functions before in mathematics, where you've got a domain and you're mapping it to a codomain, a range, right? You map one thing to another thing. You can compose a function. You can map A to B, and then you can map B to A by composing a bunch of maps together. For example, if I just had my full name, Christopher, and I wanted to get my age, how would I do that? Well, I would get my name is equal to nicknames dot get Christopher, right? And then I want my age. This gives me the key to the second map. So int age is equal to ages.get name. Right? And then I can print it out or do what I'm going to do with it. There we go. Let's run this and see if yep, I'm 30. Right. It's not lying. All right, so I'll go ahead and put this in the notes so that you have this snippet of code. But you can arbitrarily map stuff to whatever you want, so that you don't have to, do low-level kind of stuff where you're doing your own bookkeeping in a traditional array anymore. You've got way much more power now to do things with these dynamic collections. So maps. Again, a map can map an arbitrary type of object to any other type of object. They don't have to match. Right. Here's the motivating example that we did, and it's in your notes now. Right. All right, thank you, it's better now. What does the new next to hash map perform? Good question. You saw the new keyword in your lab yesterday. We wrote that code so that you didn't have to, where it creates a new instance of that object. So when we created Tom, Dick, and Harry, right, we had to create a new child, another new child, another new child. Now, that new keyword is doing what's called, it's invoking what's called a constructor. In object-oriented programming, you've got objects. Well, objects are not just numbers. They're not just like integers or doubles or chars or something like that. Objects are user defined. So what is a child? Well, a child has a first name and a last name and an age, et cetera, et cetera. All those things can be encapsulated together. It's kind of like a structure, if you're familiar with that from CS1 in C. But you also have methods inside that structure. And that's what we call an object. Well, if you want an object, you need a way to create an object. And we call those things constructors. And the new keyword here is creating a new hash map. It's constructing a new instance of this object so that you can use it. When using a map, can we use more than 2 different inputs? No, but you can create a class that has 4 elements, and then use that class, like my for tuple, my awesome for tuple, and then I can use that to map to anything I want. Right? You might be thinking Python, where you can automatically do tuples with an easy, not curly brackets, but parentheses. You can't do that in Java. Okay. Let's see. Where can you access the lecture notes online? Again, those are going to, that was posted on Piazza. Go ahead and search in Piazza for lecture. After the first lecture, I posted the GitHub link where I check these in every day. Okay. All right. So going on, let's see what else do we need. Let's talk a little bit about. Well, you're eventually going to have to do some file I/O, right? So where do I want? Oh no, let's talk about strings first. All right. So if you are coming from a C background, you will know how not difficult, but challenging strings are, how much of a pain in the butt they are. Why? Because in C, a string is nothing more than a character array. And that character array can be any size. The end of the string is denoted with a null terminating character. Not so in Java. Java has a string class. All right? You do not, no end-line characters, no figuring out how big of an array you need, etc. Right? Java takes care of it for you. I shouldn't say end-line characters. What I mean, null terminating character. Right? You don't have to make sure that your strings are terminated with /0. Right? That's the null terminating character right there. There. Now it's null terminating character. Right? /0, that denoted the end of a string. So you could actually truncate a string in C and make it shorter. You can't make the array shorter, but you can make it the string itself shorter by cutting it off with a null terminating character. And then if you take this string and you concatenate it to another string in C, you have to make sure that there's a big enough, that there's a space enough for there. And then you have to read the documentation, find out, does it insert the null terminating character for me? Well, under these conditions, it does, right? Don't have to worry about that anymore, right? If you want to concatenate, go ahead, right? You can concatenate strings or any other type of object, which gives you a string representation of it, right? Using the plus string concatenation operator, right? So, very, very useful. You just string strings together as much as you want. Much fewer headaches, but there is a gotcha, right? So in C, if I've got an array of characters, I can put whatever I want in there. If I've got HELLO, lowercase HELLO, and oh no, I needed to make that an uppercase, you can do that in C because in C, strings are mutable. You can change them after you've created them. In Java, you can't. In Java, strings are immutable. Once created, they cannot be, well, they can be destroyed, but you don't destroy them. The Java virtual machine will take care of it for you if you no longer need them. But you cannot be changed, right? Mutation, mutable means changeable. Immutable means unchangeable, right? So what do I mean by that? Let's go ahead and go over here and do a quick demonstration. Let's go ahead and do a string s is equal to hello, right? Now, normally in like say C, I want to make that into it's initially a lowercase letter. I want to make that into an uppercase letter. In C, you would do something like this, right? A single character, and then you would assign that value. That's because in C, strings are arrays. Not so here. String is a class. So this doesn't even know what you're talking about. Right? Remember last time we were able to get the character of at a particular location in a string using char at, s.char at, right? Let's go ahead and get that first character, h, char c is equal to this. And you can see that that indeed does get the character lowercase h when I run this, and it prints it out, right? The problem is there also a set char at, like s.set char at 0 to be uppercase or uppercase h? No, there is no such method, right? Well, maybe I misspelled it. No, you can't do that. Once you've created it, it can never be changed, right? If you need to create a string with a capital H-E-L-L-O, just create a new string. All you need to do is use the assignment operator. It's not like C where you have to set up the array and then you have to do strcpy, etc., right? You just have to create a new string, so big deal. But it does have implications. If you're doing string processing, there is a whole bunch of functions that you can use. Java string. So in C, for example, if you want to tokenize a string, split it up along some token because you're doing CSV data or something like that. Or if you want to take a substring, I only want this part of the substring, right? Then you have to basically roll your own. There is a string library in C. It's kind of limited, but you can use all those functions and get more complex behavior. In Java, you have way more at your disposal here. First of all, these are constructors, other ways of creating strings. But you can get the particular character at. I wonder, you can ask whether or not it contains a particular subsequence. You can concatenate, but why? Just go ahead and use plus. Content is equal. Is this string equal to that string? We'll talk about string equality later. But you can format, you can dump it to a character array if you really want. I wouldn't recommend it. You can ask, where is the first instance of a particular character? Where is the first instance of a particular substring, et cetera, et cetera. There's a whole bunch of things that you can do here, right? One thing that I want to do is take a substring. So let me just go ahead and search for a substring. Oh, hey, nice. There is indeed a substring function, method, whatever you want to call it. Come on, I have to go all the way down. There we go. In fact, there are a couple, right? There's one that returns a new string, emphasis mine, a new string, right? And we're going to see what the implications of being immutable here in a second. But I want a string that begins at a certain index and then like halfway through and then all the way to the end. That's what you're shopping for right there. If you want a substring that begins at a certain index and then only goes up to a certain index, there's a version for that too. Right? Very, very rich library here. So let's go ahead and try it out. Let me go ahead and change this to hello world. And I don't, again, I'm not going to be able to change it, but you can see the implications of what I'm about to do here. I only want the substring that starts with the W. So where would that be? S.substring at what beginning index? 0, 1, 2, 3, 4, 5, 6. There we go. Okay. So code-wise, it looks like I've changed this string, right? But I said I want to make this into a substring that only begins at that capital W and then goes all the way to the end. Let's see if I've actually changed that string. And to prove to you, I'll go ahead and print it out once before and once after. It had no effect. Why? Again, emphasis mine in the documentation here. It returns a new string because it has to. You cannot change a string once it's been created. Right? To emphasize that, let me go ahead and create another string here. Or let's go with string t is equal to s. In other words, I'm going to make two references here, s and t. And they both point to the same hello world string. Now I'm going to change s. I'll say that s is now equal to goodbye world. And let's print them both out. system.out.println s and t. What would you expect to happen here? What is s? S at this point should have the value goodbye world. What about t? T, I made it point to s, and at the time it had hello world, but then I changed s, right? I didn't change s. I just changed what it pointed to. So when I print out t here, it's still pointing to that original string, hello world. Right? There are two strings in memory here. There's hello world and there is goodbye world. Initially, s is pointing to the first one, hello world. Then I say s is going to point to the same thing that t is pointing to. And then I say, okay, now on the line 16, I say s is no longer pointing to goodbye world, or s is no longer pointing to hello world, it's now pointing to goodbye world. Did I change this one up here? Nope. So hopefully my fingers are enough of a graphical depiction of that, otherwise I can write it out. Strings are immutable. And that's why it didn't work up here. What would be the solution? If you want a substring, you need to save that off into another string. String sub s is equal to this. And now when I print out sub s, and I'll get rid of this stuff here, just so that we don't have too much stuff in our output, hello world and world. Right? Cool, right? But strings are immutable. You have to, anything that you use in the string library will give you a new string. It won't touch the original string because it's immutable. Okay, well, what if I really, 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 really want a mutable string? You can. There is something called a string builder. There we go. And I'll just call it SB equals new string builder. And initially, this is going to be an empty string. You can do whatever you want to it. You can add stuff, you can append stuff, you can prepend stuff, you can change it to all caps, etc. And only when you dump it to an actual immutable string does it become an immutable string. But otherwise, it's a string builder. You can build it, you can take it apart, you can put it back together again, you can reformat it, you can do whatever you want with it. I don't know that it has any connection to the trick of swapping two variables. But it's all about immutability, that you can't change it. And by the way, immutability is a very, very good thing, right? All caps there, very, very good thing. Why? Because it makes all of your objects thread safe. Right? And we live in a world now where there is no computer that does not have multiple cores on it. Even your phones probably have at least 2 cores on it and to do threaded computing, parallel computing, etc. Right? So it's a very good thing because if nobody can change this thing right here, that means that you're not going to have any conditions where one thread comes in and changes it and pulls the rug out from another thread. Right? We'll get to that later. Okay? A string builder here, if I want to add to it, I can say append. Hello, comma, and I can change it. sb.append. How are you? Right? And then I can print it out if you want to show that it is actually holding those values. And then I can change it. Right? So you'll see here that hello, how are you? Uh-oh, I put in one too many spaces there. Let's go ahead and take out one of those spaces. sb.remove, I think it is, remove, replace, remove, nope. I don't remember what it was, so what do? I RTM, read the documentation. Java string builder. Find, remove, delete. So it deletes, delete character at. That's even better because I only want to delete one character, right? But otherwise, if you wanted to delete an entire substring, you can start index to the end index here. So delete. And if I want to delete it at index 0, 1, 2, 3, 4, 5, 6, or 7, I just want to delete one of them, then I can show you that, in fact, it is changed. Oops, delete char at. That was the method name here. And you can see there, okay, now it's been fixed. Right. So if you want a mutable string, you can. It's just a string builder. there are some examples that I'll put in the notes there. There we go. All right. So at this point, I want to go back to our Gantt chart. So hopefully you did. I haven't graded them all yet. I think I've only graded about 20%. So on my part, I'll put down 20% there because I haven't completed my part of Lab 2. Hopefully your Lab 2s are 100% complete. We outlined our program. You remember that we were working on this program to do a suffix array, which is a lexicographically sorted array of suffixes of a string. So if science, remember that all the suffixes are the letter, and then you cut off the first letter, then you cut off the first two letters, etc. You only take the ends of them. And then you put them into a collection and you sort it, okay? So let's go back and continue. Since I already outlined it, right, let's continue with it. I need to create a collection of suffixes. At this point, we've covered enough Java that we can do this. So I said collection here. What's the most appropriate collection? Do we want a set? Do we want a list? Do we want a map, right? We're shopping for a data structure here to help us. If you really want to, you can go with an old school array, string, suffixes. Right? Does anybody really want to do that now that we've got much more powerful things? Probably not. If so, as a first draft, if it helps you, go ahead and do that. And then go back and refactor it and update it to a much better use of a smart data structure. So, what kind of data structure should we store all the suffixes in? Remember that we're going to want to sort it, right? So a map is kind of, well, what am I mapping to? It's just a collection of strings, so probably not a map. A set or a list. I want to sort it eventually, so which one of those things is ordered? A list. So let's go ahead and go with a list of integers. No, suffixes are strings. Let me go ahead and suffixes is equal to new array list. Old school Java, you would have to provide the parameterization at both of these points. New school, as in the last 10 years, I believe, you don't have to. You can elide it away. You can remove it because the compiler is smart enough to figure out, okay, well, there's your parameterization on the left-hand side. You don't need to write it on the left-hand side. I know what you're talking about. Right? And I do need to import these things. These are all java.util collections. So make sure that you're also importing the correct things. Java array list util, and these will all be imported up here. Okay. All right, well, I've got my collection here. It's complaining about the input and the suffixes because these are two variables that I've not used yet. Well, now we're going to use them. What I want to do as, say, again, if it helps you to outline things, 2A, iterate over the characters in the input and build substrings starting at each. Then place them into your collection. Right? Plain old English, right? That's not even pseudocode, which is something we'll talk about much later. Right? So help me out. How do I do that? How do I iterate over the characters in a string? Well, there are lots of ways you can do it, but let's go ahead and go with a simple loop. A for loop or a while loop? Which one? For? Okay. Why? Because we know up front how many iterations we're going to go through. The string, science, is however many characters is in it. So it is a 0 index, so I'll start my index at 0. Right? While it's less than some value, how big is the string? If this were C, it would be strlen, right, of that string. But the input dot, is there anything that will help me there? You really have to squint there, or if it's at home and you've got really bad resolution, let's go back to the documentation. Right? So is there anything in here, not in the string builder, but anything in here that, sorry, will tell me the size, oops, no, the length of the string is empty. There should be size. Okay, there, length. All right. Remember that we use the dot length property on an array to know how big of an array is, but a string is not an array. You could dump it to an array and then operate it like old school C, but this is Java. Why are you programming, C style in a different language? So input.length. And I do use the parentheses there because it is a method that tells you that there are 4 characters in this string, right? I++. There we go. So now let's just run that through our heads with HELLO, right? It'll start at 0, and how big is it? Well, it's 5. So 0, 1, 2, 3, 4. And since this is a strictly less than, when it gets to 5, outside the scope of the string, then it won't execute, okay? So I is my beginning index. And in fact, you know what? It represents my beginning index. Why didn't I call it beginning index? Well, because I'm in the habit of writing for loops with I, J, K, right? This is perfectly fine style. Let me show you a trick, though. I think that this trick was in the first video. If I wanted to rename this, of course, I would have to write it out, copy pasta everywhere. Or I could go ahead and right-click it and go down to refactor, rename, and I don't like I anymore. I'll go begin index. And like magic, all references to that variable are changed all at once. If I had 50 references, they'd all be changed at once. Very, very convenient. Very, 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 very productive once you learn tricks like this. Another excellent trick is code block mode. Oh, nope. Now I forget how to do it. Nope. Nope. Key combo. There we go. Ooh, I can copy paste a block of text rather than line after line of text. For example, I can also select a column and then start typing. All right, so very nice way of getting quick data processing using tricks like this. Getting out of that mode, just go back. On a Mac, that's going to be Option Command A. It's code block, or it's block selection mode is what it's usually called. Okay. All right, I'm iterating over the characters in the input, and I need to build substrings starting at each. We just looked at that, right? Fine, substring. All right, those are replacements. Oh, okay, substring at the beginning index, right? Let's go ahead and get each one of those substrings. String s is equal to, or I'll just use s here, input dot substring, starting at my begin index, right? In fact, code completed it for me there. Awesome, right? Now, I'm not doing anything with that. Let's go ahead and, poor man's debugging here. Let's make sure that that is actually working, that our loop is correct. Should I be writing output statements everywhere and running? Looks like it's nice. Looks like it's good to me. Computer. That's the one that we did instead of science. We did computer over here, right? So it looks like it works to me. But is that the way that you want to live your life? Printing stuff out every single time, getting rid of it. Now there's a bug. I need to restore it. Go back. I'll just leave all those print statements in all at once and have a big giant screen of output, and then I have to find where I'm looking for all this stuff. No, don't do that. Right? What should I do instead? Set a breakpoint. You can't see it because it's below this warning now, but I can go ahead and go into a debugger. Right? And I can see, well, is this actually going to work? And let's go ahead and start walking through it. Oh, I already had a breakpoint up here. I should have gotten rid of it. Sorry. Okay, that works. That works. All right, let's go through this first iteration here. You can see that actually, unfortunately, it's not going to work because I don't have another line in here. It's just going to jump right back up there. S is going to go out of scope here. So let me stop really quick and create string S. I'll create it up here so that I have the reference so that it actually exists. There we go. And now all I have to do is, there we go, there's S. So it's computer, step over that, and now it's computer, step over that, computer, right? And it looks good to me. Right? Proper debugging techniques will save you a lot of time going forward. Just use a debugger. Don't use a bunch of print statements. Right? Print statements are fragile anyway. Okay. Once I've got the substring, I need to put it into my collection. Suffixes dot add s. Right? And you're done. In fact, I'm going to go ahead and restore what I had before there. I'm going to limit the scope of that variable to only the loop. A new variable is going to be created each loop, and then that's what gets put into the collection. And what I can do is I can set a breakpoint at the bottom here, at the end. No, I can't because there's no line there to break at. Let's output the collection system.out.println. What suffixes. And this one I will output it because that's part of the assignment. But is that sorted though? Nope. But we are done with part 2 and part 2a. And if you don't care about the formatting, then of course you can go with this. Or I could go with what you learned yesterday in lab, an enhanced for loop. For each string s in the collection suffices, suffices, I will go ahead and output that particular string so that I have one to align to match the expected output over here. But of course it's still not sorted, right? So, like any good programmer, I just still don't know how to do that, so we'll go ahead and put it into to do there, and then we'll come back to it. Right? I also demonstrated in the lab 1 that this is not only good practice. It's not just something that you're lazy and you don't want to do it right now. You have IDEs that can collect all those things, and I've got all these tasks that I need to do, right? Implement this, implement that, right? I left a whole bunch of to-dos of things that I didn't want to do at the time, and I can look at these tasks and I can click on them, and then it'll take me there if I need to clean them up. Once you're done, of course, that needs to go away because you did it, right? It's no longer a to-do. For 2a, can you use an enhanced for loop? 2a, this part, not easily. I mean, you could. You'd have to create a collection, though, with a bunch of all of your indices in it. Right? All this is doing is counting 0, 1, 2, 3, or 4, right? So if you wanted to use an enhanced for loop, you'd have to build a collection that contained all those things. 0, 1, 2, 3, 4. You can use modern Java to do some kind of a functional style where you might be thinking about Python where you can go, there's this thing where you can just say range, and it'll automatically give you a collection 0 through n-1 in that range. But Java doesn't have that. Modern Java does have something like that, but that's kind of overkill for just a simple for loop. Another question? Nope, that was it. Okay. So back to the drawing board. We need more Java. Right? Before we get there, though, let's talk about the next thing. In fact, this is a pretty simple program. I've put everything into the main, right? Now, for more complex problems, you probably don't want to do that. You want to separate things out into different classes, and just coming from a C background, you want to separate things out into different functions, right? You don't want, it's called the God anti-pattern. You don't want to make your functions or your methods God. You don't want them to do everything, be everything, and see everything. You want functions to be as small as possible. You want them to do one thing, and you want them to do it well. And then you can reuse that function over and over again, right? So I don't know if there's any way we can split these out. We could potentially, have an input string here and then get a list of suffixes, and we can put that into another method. Right? But first, we need the syntax for doing that. So methods in Java. Right? In Java, we call functions methods, because in Java, everything is a class or belongs to a class. You cannot have just this function that's sitting out in the ether somewhere, globally scoped or whatever. It has to actually belong to a class, just like the math class that we briefly discussed last time. Yeah, it's Thursday. Where the math class has the square root function, the sine function, and to get it, you have to go math dot, because everything exists in that math class. Math dot, I want the square root function in that class, okay? For now, we're going to make all of our functions static. You saw this with the main method, right? What does it look like again? Static, void, it doesn't return anything, but we're using this keyword static up here. What does static mean? Don't worry about it for now, magic. Basically, it just means that that method belongs to the class, not to instances of the class. What does that mean? It means that we need to get into object-oriented programming before we fully understand that, right? You can access or invoke methods using the class name plus the method name, right? Separated by a period. Right? Actually, we don't call them periods in computer science. We call them dots. Right? You've probably seen that before in C. Where do we use the dot operator? Structures. Right? And then when we had a pointer to a structure, we used the arrow operator. Same thing in C++. But the dot operator is C-style syntax. If you have one thing and that thing has other things, how do you access those things? That thing, dot, and then the thing that you want. Math, dot, square root, gets you that square root function, right? In general, you can usually, for now, I'll say, we'll make all of our methods also public so that any piece of code can use them, right? Invoke them. Just like I did with that public static void main method, right? So for now, just understand that and this is going to change in like a couple of weeks, but for now, if you want to make a function or if you want to make a method, just go ahead and make it public static, right? So otherwise, after public static, you define the return value, return type, right? It could be, of course, void. You could return a double. You could return a string, etc. Right? You just have to make it return that value and use the return keyword. Right? That's even in Python, you would do something like this: def. And then you define a function. At the end of that function, if it's a non-void function, you still have to return something. And the return keyword is used in almost every programming language that I can think of off the top of my head. Right? At least procedural style programming language. Right? That has functions, okay? So, I don't know. Here's an example. Let's go ahead and do an example. Let's do that. Let's go ahead and separate a little bit of this by saying that this is too complicated. 1, 2, 3, 4, 5, effectively 4 lines of code here. It's too complicated. I'm going to put that into a function so that I can reuse that function, because I've also got this program over here that really wants to build suffix arrays as well, right? So let's go ahead and take that and put it into its own function, right? Now, let me go ahead and not do that just yet, because of course it'll be a compiler error. But let's go ahead and make another function to do that for us. Public, static. Oh, what's its return type? Well, let me name it first so that we know what is this function going to do. And usually you use a verb name, or verbs, right? That this function does something. So you could say that it computes suffix array, right? Suffix collection or suffix, because it's no longer an array. Suffixes, compute suffixes, get suffixes. We're not too creative in computer science. You will see these are called getters, right? They get this thing over here. And why? Well, I want it to produce this thing, and production of this thing is a verb. So compute it, create it, make it, just get it. And so we like to simplify those things. Now, what is a suffix array? Well, we've defined it as a list of strings. So that's my return type here. Public, static, and what are you returning here? I'm returning a list of strings, okay? And then any inputs you put in, just like you would in another language, you would put the inputs into the parentheses there. If you're coming from a C background, this looks familiar, of course, but we don't have prototypes. If you no prototypes at all. You just declare the function and you can use it. I could even move it down here. Ultimately, I'm going to use it right here, but I don't have to put it there. I can put it down here. Now, style dictates that the main method is at the bottom, so I will put it up here. Right? Get suffixes. Now, before I continue, one thing that I do need is documentation. Actually, let's finish out the signature here first. What should it take as input? String. And since it's just called input, I'll just go ahead and say that it's input. Right? And of course, I'm not returning anything right now. And you'll notice that a lot of people got tripped up, at least initially, because to make things compile, you actually have to complete it. So I'll return null here. Right? You'll see that a lot of our starter code is returning some default value, 0, null. Right? That's just to get it to compile. Right? A lot of people miss that I have to change that 0 down at the bottom there. And then when they weren't passing any tests, then it was pointed out, no, okay, that's the fix. Okay? For now, I'm just going to return null, nothing. Right? And then I'm going to fix that later after I've actually written this function. I've already written it, but it's down there. But before I do that, I need documentation. Java doc style documentation, you can't go wrong. Right? Not that we're going to require it in your assignments, but you should just start getting in the habit of doing it. Not only in Java, but in C, PHP, any programming language is going to support this doc style comments, where it is a /**, and then these are meta tags, basically. It's saying that the parameter is this string input here, if you wanted to document that, the input string. It's kind of self-documenting, so a list of the suffixes of the input. Right? And input is actually code, so I can highlight that as code. What does that look like when I hover over it? You'll see that it's you can't see it very well because it is small, but it is formatted in monotype font, so it looks like code. Right? And again, you can embed links in there if you want to. Right? I don't need to do that here, but I'll document this function. This method creates a list of suffixes of the given input. Right. There. Now, in general, all non-trivial methods need to be documented. This is a non-trivial method because it actually does something. Main? That's a trivial method. I know what the main does. It runs the program, right? You don't need documentation on the main. All it would be is runs this class. That's what all documentation on main methods would look like for the rest of your life. That's pointless. Don't do that. Right? You don't, or at least you don't have to. Some libraries, of course, will be pedantic and they'll do every single one, but just to be consistent. But no, it's not required here. Okay. Now I'm going to steal this code, move it up here. There. I've created an array list, which is a list of strings. I've added them all to it, and of course now I'm getting a compiler error because I erased my return statement. I return suffixes. There. And I can use it down here. I want to get all those suffixes of the input. Now it's working here, but it's working for the wrong reasons. So I do suffix array, right? Remember that that you access a method using the class name, a static method that is, and then dot, and then the method name. And you note here that it's italicized, and that's because it's static. We'll come back to that with object-oriented programming. Of course, it's returning something that I have to then put into a variable because, well, what's suffixes? Suffixes is a list of strings. And now I'm computing it in that method right there. Right? So I took 1, 2, 3, 4 lines and put it into its own method. Again, there's no hard and fast rules on this. Right? In general, if it's a one-liner, no, you don't make a function for that. Right? If it's a 2-liner, I don't know. Maybe if it's a 3-liner, maybe I don't know. Right? There's a whole fuzzy area in there. But if you've got something that is 1,000 lines, no. That's way overstepping the line. That needs to be in its own function, right? Or that needs to be in a series of functions or something. Right? If you find yourself reusing this chunk of code, this snippet of code is so useful that I've cut and pasted it over here. That's a huge red flag, right? that don't repeat yourself. DRY principle. Don't repeat yourself. Put that into a function and reuse that function. Right? So again, it's more art than hard and fast rules. Okay. And that's an opportunity for you to speak to your partner when you're designing all this stuff on the project and say, you know, that's getting kind of complicated. I think we should put that into a function. Well, no, I think that's you're over-engineering. So just as we have the DRY principle, don't repeat yourself, we also have the Yagni principle. Yagni. What does that stand for? You ain't gonna need it, right? Or you aren't gonna need it if you want to speak properly. You ain't gonna need it, right? Don't prematurely optimize things. Don't over-engineer things. Do we need to take these 5 lines and separate them out into 5 methods? Are you going to reuse those methods? No. Then you ain't going to need it. Right? All right. So you know what? I'll take. I'll post this at the end so that you can see the syntax for that. Otherwise, I'll go ahead and copy paste another example here. There we go. Right. Mark it up as Java. Okay, it's refusing to do that now. There we go. Now it does it. All right, so I've got Java doc style comments there. All the most of that can be automatically generated by your IDE. If you just go /** hit enter, a lot of this stuff will be generated for you, and you just have to go in and fill the blanks. This is a Euclidean distance function, which takes 4 doubles, right? An XY pair over here and an XY pair over here, and computes the distance, the Euclidean distance between those 2 points, using Euclid's formula here of x1 minus x2 raised to the power of 2, and then the y components, the difference there, raised to the power 2. And then you take the square root of everything. Lots of math dot, math dot, math dot. You don't need to import that. You don't need to include it. It's all part of the language itself. Okay? All right. All right, let's talk next about any questions about methods? Otherwise, again, you'll be making methods, but should I make this into a method or not? That's a design decision that you then have to mull over in your mind, and that's why it's good to have a partner, because then you can bounce those ideas off of each other. And that's also why in a couple of weeks we're going to have a guest lecturer come in. We're team up for it, but from the Writing Center. When you do writing, what's the best practice when you're writing, say, an essay? A first draft, and then a second draft, and then a third draft, fourth draft, fifth draft, right? Coding is exactly the same way. You may think, okay, well, this needs to be into its own function, or maybe you go the other direction. No, it doesn't need to be in its own function, or whatever design question you've got at the moment, right? You've got a couple of choices. You write out those choices, and you go, okay, well, let's go ahead and go with the first draft and try this avenue. Later on down the line, you hit a roadblock because that turned out to not be the case. It turned out Yagni was true. You ain't going to need it. So let's go ahead and back up and try a different approach, right? Let's go ahead and back up and try that alternative approach. And that's one thing that you're going to be putting in your design documents. Anything that you say eventually, well, this is a bad design because I'm fighting it, right? Because there are consequences to this design. Document that in your design document. Say, we try. It's not failure, right? We learned something that this was a bad design. Here's why it was a bad design, because it is a message to future designers. Don't go down that path that I did, and here's why, right? It's like those Stack Overflow questions that never get answered, right? That we talked about, where you have a question on Stack, and then Stack Overflow comes up, the exact problem that you had. Okay, excellent, somebody's had this problem before, and you go down and you don't see any answers. You just see the original poster said, oh, I fixed it. That's not useful, right? How did you fix it? Because I have the exact same problem. Right? Documentation and design documents allow you to kind of keep track of those things. Okay, and you only get that if you try different drafts of code, try different drafts of your design documents. Right? Let's talk about file I/O, because you will be processing files. In fact, I think that your protein sequencing is the second assignment. In fact, and then processing all that CSV data is another part of that. So let's do some file input, right? File input. Now there are dozens of ways of doing this. I'll show you the easiest, right? And by easiest, it's not necessarily the best, right? We pay a cost for simplicity. The cost that we pay for keeping things simple is that they are not customizable, right? That they are if we've got a tool that has like a Swiss Army knife that has 50 different tools that you can use, right? All I need is a knife, though. So what I'm doing is I'm giving you a knife. If you also need to open up a can opener, or if you also need to do a bunch of other things, then there are other ways of doing that that give you more flexibility versus simplicity, right? And the way that I'm going to show you is the easiest, the simplest, okay? To do that, of course, I need a file first. I've already got the input files here. Let me go ahead and create a new file that is similar to something that you're going to do throughout the semester that you've already done, data.csv. CSV stands for comma-separated values. So hello, how are you today? And I don't know, 42. No, let's actually make some real data here. So my first name, last name, my last name's not last name, the city that I live in, and my age, which we already established was 30, right? Tommy, let's go with Hodavi. Anybody know him? Oh, you do?
Yeah, he was my today last stuff.
Oh, no, that's a different Hodavi.
Oh,
He's the pitching, but yeah, I've meant to ask him if he's related at all. I highly doubt it. But to Tommy Hodavi, the pitching coach for the Chicago Cubs. I have no idea how old he is. Let's just say that he's 35. Right? And I only know, so that's only special to me personally because as a Cubs fan, of course, but also because he played for half a season with the minor league team for the Royals, which are the Storm Chasers, the Omaha Storm Chasers. And he happened to be playing when they were doing a jersey raffle. And of course, he didn't have a very successful pitching career, so nobody knew who he was, and neither did I at the time, but I bid on his jersey, I won his jersey. And then he went on to become the pitching coach for the Chicago Cubs, my team, and so I've still got his signed jersey, and it's awesome. It's awesome to me. You probably don't care about any of that, right? But anyway, I've got some CSV data here. Let's actually start processing it. I don't want suffix array anymore. I don't want the input or the output anymore. Oops, sorry. If you ever get yourself into trouble with your Eclipse, you can double-click a tab to give yourself more room. Double-click on it to restore it. If you ever accidentally close something, Project Explorer, I'm dead in the water now, right? I have to reinstall everything. No, you just go up to Window and Show View, and then there are a bunch of things that if you end up closing them, you can restore them. Package Explorer, and now it's back. I don't like my Package Explorer on the left-hand side because I'm left-handed or something. I don't know. I'm going to go ahead and move it over here. You can do all that kind of stuff, right? Or let me go ahead and restore it so it's on the left-hand side. Window, Show View. You're not going to see it because it's on the other part, but Package Explorer. There we go. Okay. It restored it to where it was before. There. And of course you can move stuff around, whatever, right? Demo, there. All right, get rid of all this. So to process a file, of course, in C, you'd have to open up the file for some mode, reading, writing, or whatever. And then you'd have to process it, say line by line or character by character, and then you'd ultimately have to close it. So what I'm going to do is I'm going to show you all that in one. Basically, it's the same concepts, it's just a little bit different. The easiest way to process a file is to use what's called a scanner. A scanner scans something. You can create a scanner for standard input. If you want to type at the keyboard or whatever, it'll scan the standard input. If you want a scanner for a file, all you need to do is pass it a file when you create it. I want to create a new scanner based on this new file, and then I provide the file name. All right, file name here. Well, what's the file name that and of course I'm going to have to import all this stuff, so bear with me here while I import this. There we go. And you start seeing that there are more packages, right? Come on. Okay. This is a different issue, but it's not letting me expand these things out yet because of another issue, but that we'll fix here momentarily. But anyway, what's the file name that I just created? It was data.csv. All right. That's not where the file is located, though, is it? Where was this file that I created? It's in this, or where, that's a good question. Where did I put it? Oh, you know what? Am I in assignment 1? There we go. There it is. Different project, sorry. There's data.csv. In fact, I can close this and show you it's still that file over there. Okay? It's in a folder called data at the root of my project. So in order to open that up, I need to say that it's in the data folder or directory, and under that there's this file called data.csv. That's not what the compiler error here is. The compiler error is something that we'll talk about right after this. Unhandled exception type file not found exception. So 2 fixes. You can either add a throws declaration or surround it with a try catch. The first option here is usually the wrong one. The second option is usually the right one. Right? What is a try catch? With error handling in C, say, you take a defensive approach. You look before you leap. In Java, it's the opposite. Go ahead and leap, because we will catch you if you fall. Right? So go ahead and try this dangerous code. If something happens, don't worry. We'll catch you and bring you to this chunk of code right here so that you can handle the exception. That's the concept. We'll cover it in more detail later on. Just know right now that for certain operations in Java, because of a very bad design decision that they made 25 years ago, means that you have to surround certain operations with a try-catch block. If you don't, then it's a syntax error. Okay? This is one such. A file not found exception, if that file is not there, you certainly can't read it. And so it throws this exception, and you need to deal with it. If there's no such file, in fact, I'll go ahead and misspell data, and we'll see what happens here. Let's run this. No such file exception, because there's no file called dta.csv. Right? Let me go back and correct that spelling. And when I do that, I don't get that error, but of course I'm not doing anything down here. That printing of the stack trace is what was going on down there. All that blob of red, that was an error. That was me printing the stack trace here. Right? To do auto-generated catch block. To do, we'll worry about that when we cover exceptions. Okay? Probably get into next week here. But for now, just know that you've got this try catch. Okay? Now, to do, process the file. To do. If you open a file, you certainly have to close it. Except I didn't really open a file. I opened a scanner that's scanning the file. So the scanner is what you have to close. Looks familiar, right? For close, well, s.close. You close that scanner. Okay? The scanner is, of course, only for reading. The scanner doesn't write to a file. So how do we actually process the file? Here's the easiest way. If you want to process it line by line by line, I don't know how many lines are in there. I know by looking 2 lines, right? But if I want to process this line by line by line, then I need some sort of a loop. What kind of a loop is more appropriate here? A while loop. While the scanner still has something to read, the scanner still has a line to read, right? I'll go ahead and read the line. I'm doing outlines here, right? A now. Read the line, right? Process the line, that is, tokenize it along commas, right? And I want to know what the age of each person in the CSV data is. So process the line, I'll tokenize it along those commas, find the age, and print it. Right? So that's what I'm going to do. Right? Data Remember that it's first name, last name, city, state, and then the last one is the age here, okay? So let's go back and fill in these blanks. How the scanner has a line to read. Well, S dot has a lot of stuff here. In fact, has next big decimal, has next double, right? I want to read the next double. I want to read the next character. I want to read the next line, right? I want to read the entire line. So how do I read a line? S dot. I think it's fine. There we go. You can do partial 2 here. It's kind of small. You might not be able to read it, but it's next line. Right? Let's save that off into a string. Read the next line. Process the line. I want to tokenize it. Remember that it's going to be this string right here. Right? 2 questions that I have in the back of my mind, though, coming from a C background, is what about that end line character? Is it retained or not? Do I need to take care of it or not? And then another one is tokenize. That's in C I would use strtoke, right? I wonder if there is something in Java that will help me do that. Find tokenize. Nope. So too lower. Trim. A verb called split. That sounds like it might be useful. Let's go ahead and read that. Splits the string around a given regular expression. What's a regular expression? That's something that you should pick up because regular expressions are super, super useful. You can create a regular expression to match any phone number and pull all the things that look like phone numbers out of a file. You can create a regular expression to match emails and pull all the emails out of a file with one line, right? For us, though, it's simply going to be, well, here's a delimiter. Right? If you have colon separated values, it'll split it around a colon. Right? But I don't have colon separated values. I have comma separated values. Line dot split commas. Okay. What will that return? I need to read the documentation. It'll return a string array. But wait a minute, Dr. Burke, you said that arrays suck. Yes, they do. This was created in very, very early Java before they even had dynamic collection, parameterized dynamic collections. So Java bends over backwards to be backwards compatible. Why isn't there a list of strings or a set of strings or a collection of strings? That would be nice. It would just be something that you have to add to the language, and now you've got 2 things that do the exact same thing with just a different return type. Right? I'd argue that yes, it's worthwhile enough to do it, but I don't control Java. Right? You can through a public process propose changes to Java, and then they have to go through a ratification process, and people have to comment on it, and eventually they might be adopted, but it's a very long, arduous process. Right? So it returns a string array. And they're tokens, so I'll call it what it is. Tokens. Find the age and print it. Well, let's look at what that looks like for a second. So int age equals 0, system.out.println age. Right? I'm going to go ahead and set a breakpoint. Come on. All right, it's not. Let's see if it actually worked. Nope. Why are you not setting breakpoints? I probably donked the editor here. Let's reopen it. There, now it's restored. There's a to-do. I'll put in, there we go, now I've got my breakpoint. Right? 50% of IT and 75% of computer science is. Maybe it's even more. I'm just making those numbers up anyway. Is restart the machine. All right, so what do tokens look like? There's the first line. Burke, Chris, Burke, Omaha, Nebraska 30. The age that I want there is the 1, 2, 3, 4, 5th token, which would be at index 4. Right? Okay. Tokens sub 4. Right? Now, is that going to work? Let me go ahead and terminate this. Some debuggers allow you to do what's called hot swapping. where it's the debugger is running, it's simulating the program. You go back and you change the code, you hot swap it out. This is not one of them. Right? So what's wrong with that line? Age is an integer, and tokens is a string. So how do I convert an integer to a string to an integer? Integer.parse int, in this case. If you wanted to parse a double, it would be double.parse double. Cool. And now I've got a token here. Or now I've got that value. And I can print it out as an integer. When I run this, it should run 30, 35. Okay? Let me add something else here. Because it seems to work, but it's actually not working. Tokens sub 0 concatenated with is age years old. There we go. And concatenate. Concatenate, concatenate, concatenate. Tommy is, oh, okay, it is actually working, darn it. I was thinking that, let's put in a bunch of blank lines here. And will this work? Nope, it will not work. Why? Index 4 is out of range for index 1, right? Why? I was blindly processing empty lines. Right? So here's another way that you can make it a little bit more safer. Once I've got the line, of course, I can ask whether or not that line has anything in it, right? If the line is blank or is empty, is what I usually do. If it's not empty, then do this thing. I've got to indent all that stuff, right? Or I can select a block and indent it, or I can just let the formatter do it for me. Right. There we go. And now when I do this, I don't get that error because all those empty lines, I'm going to end up ignoring them because they are empty. Only if the line is empty do I actually process it. Awesome. That looks good. Any questions so far? No? Then instead of printing this out, let's dump these to a file. Right. We could do it inside here, or we could create a bunch of... how do I want to do this? Okay, I'm going to take this and just put it into the notes, and then let's start over for file output because it's super, super easy. File output, right? The easiest, oops, sorry. Nope, not that one. There. The easiest way is to use a print writer. And now again, there are a couple of dozen ways of doing file output. Buffered, unbuffered, et cetera, et cetera, et cetera. Don't worry about any of those. We're going to create a file with a print writer output. Right? And let's go back over here. So, file output file is equal to new file. And I'll put it in that same data directory. If I put it in the root of the directory, then it's going to put it at the root of the file system. And, or not the file system, but the project. And then it's like orphaned. It's out in the middle of nowhere. Data and then output. Output.txt. I'll just make it output text file. How do you do binary data? Read the documentation. Usually you don't want to do binary data directly anyway. Why do you want to do binary data? Because I want to process an image, or I want to process an MP3 file, or I want to process a video. Guess what? There are classes to do that for you already. Right? There's an image built into the language already, and you can just go ahead and use that rather than processing each RGB value or whatever it happens to be. Right? I've created an output file. Let's go ahead and create a print writer. PW is equal to new print writer. Okay, we're almost out of time here, so I will cut it short, but this is where we'll pick it up next time. The print writer is the output file. I was looking at the wrong clock, sorry. That one says, well, the hour is not even correct up there. But now that I look at the official time over here, print writer, that's where we'll pick it up next time. Okay? All right.